Let's now look at the third piece in the data loader puzzle, the collate function. So our usual collate function, let's just refresh our memory on what it does. So we can see that it's giving x as an m by n vector, m by n matrix, and y as a single dimensional array. Now, let's say that we want to get y as a column vector. So we want y as an m by 1 vector. So we implement the collate function, and the input to the collate function is usually a list of whatever it is that the data set is outputting. In our case, our data set is outputting a tuple of x and y. So we'll get a list of such tuples. But let's just verify that's indeed what we are getting. So I'm just going to print out the type and the value and then just raise a runtime error. And we can just pass our custom collate function to the collate fn argument. That we get a list, the first element of which is an array, which is x, and the second element is a scalar, which is our y. So now let's implement our actual collate function so that we get a column vector for y. So I separate out the x's and the y's from the samples, stack all the x's on top of each other, all the y in an array first, and then just reshape the array to have as many rows as it needs, but just one column. And then finally, when we return, we want to make sure that we convert these into torch tensors. And we can see here that y is now a column vector instead of a one-dimensional array.